All right, so like I said, just some intro notes. You have a page that looks like this linked in your document for the day. These are intro notes. Isosceles triangles are what we're working with when we use 45, 45, 90 triangles, meaning that we have a 45 degree, and then that right or 90 degree angle. So isosceles triangles, two sides are the same, or congruent, or equal at distance. I always remember equilateral, same side, that one makes sense. Scalene triangles are scary because all the sides are different. That's my kind of memory device to keep that straight. So we have a special kind of feature of these where the hypotenuse is equal to the leg multiplied by root 2, okay? That ends up looking like this. Or we use this rule. This is a way to show this idea here, right here. In the image, we can say x root 2, okay? Now, to use just kind of a numerical example with simple numbers, we could say if those legs are each worth a value of 1 or a distance of 1, then our hypotenuse would be 1 root 2, which is just root 2. We're going to end up using that down here. Now, here we have the same examples. Mine is laid out differently just so that I can write a little bit more easily. But yours might be laid out differently, and that is okay. You have this triangle where you have a right angle here, 45 degrees here. We therefore know that we have 45 degrees up in that corner of the triangle. So in method 1, I'm going to set up a proportion where I say that W is compared to 1 and 7 is compared to root 2. Now, I typically would go ahead and see if I need to cross multiply. In this case, I do not. Okay, I can just leave it here where I have Y, which is also W, is equal to 7 root 2. Now, in the directions, you'll see something like use exact values. Exact values mean keep the radical, okay? Keep in simplest form, keep the radical. So exact values, you keep that square root 2, you do not type it into your calculator. But sometimes we don't want that radical in the denominator. So you'll see answers where there's never a radical or a square root in the denominator. To get rid of that, I want to show how you might do that. In this case, we had W equals 7 over root 2. We want to eliminate the root 2 in the denominator. So we're going to multiply by root 2 over root 2. We are not multiplying by root 2. We're multiplying by root 2 over root 2. This is a value of 1, which is why it doesn't change. 7 times root 2, we can leave that. Root 2 times root 2 is root 4. Root 4 simplifies to 2. Okay? So this value is equal to this value. But when doing multiple choice, you might see something where you never have a root in the denominator, and that's because this process has been used. A second method, sometimes I teach a table method. In the table, I first have my angle degrees. So 45, 45, 90. Across from 45, I have an x value. Across from 45, I have another x value. Those are my legs. Across from 90, I'm using the pattern x root 2. Okay, so degrees, the side length. Now here I have what's given. This is my given info. Now I know that 7 equals x root 2, right? But I want to find out what x is. And when I say x, I know there's no x in this problem. There's no side length that is labeled x, but I want to find out what x is in my original pattern or just what my side length is. So I have 7 equals x root 2. I'm going to divide by root 2. Is x. But again, there is no x. So that really tells me, so I really know that W, equals Y equals 7 over root 2. Like that. Okay? So you can use either method there. All right, I will have another couple videos in a second for the back page.